Okay, guys, I am really sorry I'm not there today, but I started feeling really bad at the end of fourth block, and I am probably asleep in bed at this point. So I am recording this on Monday night. Okay, so I'm going to go over 1 and 6 since that was what was assigned yesterday to make sure that you have it and you can check your answers. And then we'll talk about the other couple of things that we need to do, which includes taking care of top heavy, which has a different kind of asymptote, and also dealing with the holes, which was on the paper. We're going to talk about what it means to have holes. Okay, so let's go through this. So this one is bottom heavy. Okay, and we talked about that as far as that means that you need to put a 0x squared here so that your degrees are the same as far as missing pieces. What you have as far as your, horizontal asymptote is basically 0 over 1. So your horizontal asymptote is y equals 0. Your y-intercept, again, is based on your constants. And again, if you're missing a piece, just put in a 0. Okay, so 0 over -1 is still 0. Okay, so your vertical asymptotes, you have to actually factor the bottom. Hopefully you recognize that x squared minus 1 is a difference of squares, and that means it breaks down to 1 plus and 1 minus of whatever the square root is of your numbers. So that's x plus 1 and x minus 1. Let's try that again. And that means your asymptotes, since you're supposed to set these equal to 0 to solve them, are going to be x equals 1 and x equals -1. So those are your vertical asymptotes. All right, so for your x-intercept, you're just supposed to solve the numerator, right? So basically just set it equal to 0, and in this case, that means that x is also going to be 0. So your x-intercept and your y-intercept are the same, which happens very frequently when you have one at the origin. All right, so let's go ahead and graph it. We talked about this yesterday, that if there are 2 vertical asymptotes, that means that this graph has been split into 3 pieces. Okay, and that it follows a very specific pattern. And there's your x and y intercept. Since this has not been made negative, that means this side is on top, this side is on the top, and this is down here and hits that x and y intercept right there. You can prove it to yourself. You can plug in some numbers and see what you get. Let's say if you plug in positive 2, you're going to get 4 over 3. So 2, 4/3 would be about right there. If you plug in -2, you should get -4 over 3. No, that can't be right. I have it in a moment. So anyway, but you can, again, prove it to yourself as far as that goes, just to check it. Okay, so for number 6, again, horizontal and vertical asymptotes, intercepts, and a basic picture. So again, bottom heavy. All right, so 0x squared here. My horizontal asymptote is 0. That's pretty much going to be the case every time it's bottom heavy like this, because it means you're missing the piece on the top that you would need to be those leading coefficients. Okay, so this is 0. This is an interesting case because what you have is -4 over 0 for your constants. So there is no y-intercept. It just doesn't exist. And this is the only type of function that is possible to not have a y-intercept of some kind, right? Maybe a log, and that's only if your vertical asymptote on the logarithm is something in the x positive numbers. But it doesn't happen very, very often. Most functions are guaranteed to have at least maximum one y-intercept. This one just doesn't have any. Okay, so your vertical asymptote, again, you need to factor and solve the bottom. This only has a GCF. There's only 2 pieces, so it's not sum and product, right? So this is only GCF, and then you have to set each piece equal to 0 and solve. So this one does have 2 vertical asymptotes at 0 and +3. Equals 3. Okay, and then your y-intercept, again, you're just solving the numerator, so x minus 4 equals 0, x is equal to 4. All right, so horizontal asymptote, vertical asymptote, and at 3, and there is your x-intercept, and no y-intercept, and again, it's that pattern, so it has not been turned negative, so here, here, and then this is like what we talked about yesterday, is it is actually going to go through the horizontal asymptote, because that's more of a guideline for where the ends of the graph are going. So it does actually have to hit that x-intercept. Okay, so the other things that we need to go over is top-heavy and holes. Okay, so, and this is actually bringing back something that you already know how to do, or we've already gone over, so you may have to look back in your notes to check it. I'm going to go ahead and get everything else for this problem first. Okay, because I know my vertical asymptotes are just solving the bottom. All right, so 3x minus 1 equals 0. Add 1. 3x is equal to 1. And then divide by 3. So x equals a third. Which, incidentally, you're going to need that again. So just hang on to that vertical asymptote. X-intercepts are solving the top. That is 3 pieces, so it is definitely sum and product. What multiplies to give you 6 and adds to give you -5 should be -2 and -3. And since you are supposed to solve them, you have an x-intercept at +2 and +3. And then your y-intercept is supposed to be your constant terms. That hasn't changed. That is still here. Okay, so 6 over -1 would be -6. Okay, so this does not have a vertical asymptote, and here's why. If I fill in that little 0 like I'm supposed to when I have pieces that aren't, matching up, I have 1 over 0, which we already know doesn't exist. So this is how we take care of this. It's called, or what we have is called a slant asymptote. That basically means it's a linear function that acts as a asymptote on this, and this function actually looks really interesting because of the asymptote. So that 1/3 that we got for the vertical asymptote, we're going to go and we're going to use synthetic division, because what you really have to do is you divide the top by the bottom. And we can use the synthetic division. This is going to be, this vertical asymptote is going to be our multiplier. So it's 1/3. So hopefully you remember your synthetic division. We put out the coefficients. And you remember, this is like slapjack. You cannot play the game till the first card comes down. So the 1 comes down. And then what we're doing is we are multiplying, putting it in the next column, and then adding. Okay, this is just like we did before. 1/3 times 1 is 1/3. -5 plus 1/3 is a -14 thirds. Don't worry about it. Just try not to get too many decimals. Okay, multiply that. That's going to be -14 over 9. I'm not really worried about the last number. It doesn't have to equal 0 like when we were doing the synthetic division. I really only need this. Okay, so think about this. Back from synthetic division. This first term was a squared, and then this was an x, and this was your constant, right? So when you do the synthetic division on this, remember that you lose 1 degree. So this is technically 1x minus 14 over 3. This is the linear equation that is your slant asymptote. So it is really not, you don't even really need the last number. It's irrelevant. So my slant asymptote is the equation y equals 1x minus 14 over 3. Okay, so we're going to graph this just so you see what it looks like. It's kind of weird looking, but the slant asymptote, because it's a diagonal, makes it look pretty cool. So let's go ahead and graph this thing. So just so you can take a look. All right, so vertical asymptote at x equals 1/3. Roughly there. Okay, and again, no horizontal asymptote at all. It's not going to have a horizontal one because we don't have leading coefficients that'll work. So my slant asymptote, again, is 1x minus 14 thirds. So that's like -4 and 2/3. So it's right here is my y-intercept. And then it has a slope of 1. So I'm just going to go up a box, over a box, up a box, over a box, up a box, over a box. Basically just doing stepping stones for my slant asymptote. Okay, so you see how this is now on a diagonal. All right. So let's take a look at our other pieces so we can see where it's on the top and where it's on the bottom. Because it only has one vertical asymptote, you are only going to get two pieces to this graph. Okay, so my y-intercept is at -6. 1, 2, 3, 4, 5, 6, so it's down here. And my x-intercepts are at 2 and 3. Okay, so again, basic picture. That means it's on the top on the right-hand side and on the bottom on the left. And you have to do it between these two lines, between the vertical and the diagonal line. So it's going to come down in there, probably curve back up and go out. So it does actually follow the asymptotes. And the one on the bottom, again, it's going to go through that y-intercept and come back out. Now notice this one is coming down and this side is going straight up because it's following that vertical asymptote, right? The other line is following the, the slant asymptote. Okay, it is going to actually follow that diagonal line. And so that's the difference between top heavy, bottom heavy, and balanced. The top heavy ones look like this because the slant asymptote kind of makes it into a really weird, kind of almost sideways curve. But that's what it looks like. And again, you're just drawing a basic picture. Okay, so the other thing that we have to go over is holes. Okay, and again, y'all know the deal. Y'all can pause this whenever you need to. I'm going quick, so the video is not that long. Okay, so holes in a rational function occur when pieces factor out, okay? So if I were to factor this, I would have x minus 2, and again, sum and product, what multiplies to give you -6, adds to give you 1, should be +3 and -2. Okay, so this is just back to our simplifying, right? The x minus 2's cancel. What you're left with is a placeholder over x plus 3. That's really what you're actually graphing. That's what you're going to base your asymptotes and your intercepts and all that on. But because this piece canceled out, you have a hole, what's called a hole, or the actual math term for it is a discontinuity. It's discontinuous at x equals 2. So when we draw it, we're going to put basically like an open circle at x equals 2, you know, and, excuse me, at x equals 2 so that we can basically show that there is a hole in the function, okay? But everything else works the same. So let's go ahead and figure out what our intercepts and our asymptotes and all that stuff are. Okay, so y equals x plus 3. All right, so what am I doing? 1 over x plus 3. I'm having a moment. Okay, so horizontal asymptote, it's bottom heavy, by the way. Vertical asymptote, x-intercept, and y-intercept. Okay, so 0x, bottom heavy, means that my horizontal asymptote is 0. Vertical asymptote's only got 1, x plus 3. That means the vertical asymptote is x equals -3. Okay, x-intercepts. We don't have any because you can't solve the top. So you actually don't have any x-intercepts in this case. All right, and then your y-intercept, again, based on your constants, is 1/3. So 0, 1/3. All right, so let's see what this thing looks like. All right. Now, why did you move? Weird thing. There we go. All right. So no x-intercepts, y-intercept of 0, +1/3. That's about right there. Vertical asymptote at -3. Oop, -3. Messy. And or rather horizontal asymptote at 0. Okay, so we said that there is a hole at x equals 2. So somewhere, like wherever your curve would go, there has to be a hole. Okay, so remember this is just two pieces, right? And it hasn't been flipped over, right? So it's still going to only be two pieces. That means the right side is up and the left side is down. So it's got to go through that y-intercept, right? Okay, so what we're going to do is as we come out, we're going to put a hole at x equals 2. and then we're going to keep going. That's how that's going to look. And then the other side is just normal. There we go. Okay, so that's how you deal with a hole in the function. Now, the actual, let's see which ones are actually going to have a hole. I think number 4 has a hole in it, and that's it. And number 5, you're going to have to do synthetic division, right? Because it is top heavy. And then check number 3, please. You need to make that 2x squared minus 1 on the bottom. So number 3 needs to be 2x squared minus 1, because that we're not going to do imaginary asymptotes. I'm just not doing that. So 2x squared minus 1 on the bottom, and I think it's like x squared minus 9 on top. Yeah, x squared minus 9. Okay, so there we go. So change that to that. And then again, like I said, you're going to have to synthetic division on number 5, and number 4 is going to have a hole. What I want you to do is just finish these. I think, like I said, I think that's the only one that actually has a hole in it. Make sure you're listing these for each of your functions, right? You know, your asymptotes and intercepts and all that. And then tomorrow when I come back, I will go ahead and we'll talk about end behavior. Not much, because honestly, there's not much else to do when you're graphing these things, is just picking out the pieces. We'll also take a look at what they look like using Desmos. So no Desmos today, no cheating. Again, I want basic graphs. All right, take it easy, and I will see y'all the next time.